Hi, you have reached the podcast of Professor Chaim Shor. In this episode, where statistics went wrong in modeling random variation.
Where statistics went wrong, modeling random variation. A model of random variation, generated by a random variable, is presented in statistics in the form of a statistical distribution, like the normal or the exponential. For example, weight of people at a certain age is a random variable. Its observed variation may be modeled by the normal distribution. Likewise, surgery duration is a random variable. Its observed variation may, at a specified circumstance, be modeled by the exponential distribution. To date, there are thousands of statistical distributions published in the statistics literature. This seems insane. Furthermore, it stands in stark contrast to the general trend, observed in all branches of science, at unification of the objects of inquiry. Back in the olden days, when I was an undergraduate student at Technion, Israel Institute of Technology, I remember learning, for the first time in my life, that randomness too has its own laws. I have become extremely appreciative of the ingenuity of the concept of statistical distribution. The sheer combining of randomness with laws articulated in the language of mathematics, as in any other branch of the exact sciences, fascinated me considerably, young man that I was at the time. That admiration has since all evaporated. I have become disillusioned. Becoming increasingly aware of the gigantic number of statistical distributions published in the statistics literature, I realized that unification of the objects of inquiry, as witnessed in all modern branches of science, like unification of the basic forces of nature in modern physics, this effort at unification has eluded statistics altogether. No similar attempt at reaching a universal model for random variation, as observed in nature, has ever been reported in the probability and statistics literature. Why is that? Personally, I attribute this failure at unification to the fact that current foundations of statistics, with its basic concepts like probability density function, PDF, or distribution function, often denoted cumulative density function, or CDF, have been established back in the 18th century to derive various early-day distributions. Some well-known mathematicians of the time, like Jacob and Daniel Bernoulli, Abraham de Moivre, Carl Friedrich Gauss, Pierre-Simon Laplace and Joseph-Louis Lagrange, have all used same basic concepts and basic tenets as used today. Shared by all these tenets is the underlying belief that random phenomena, as observed in nature, has each its own specific version of random variation, and the latter may each be captured by its own specific statistical distribution. A major result of this stagnation, this freezing of any thought process regarding how to best develop a general model of random variation, this stagnation has to date prevented, within statistics, any form of unification of the objects of inquiry, as it is currently witnessed in all other branches of science engaged in describing nature. Recently, I have been engaged in a comprehensive data-based research work at statistical predicting and monitoring of surgery times. This research effort has produced 3 published papers of 2020 and 2021. See references below. For podcast listeners, see corresponding post at chaimshor.blog. Pursuant to this research project, a new paradigm to model observed random variation has been conceived and developed. It is denoted the random identity paradigm. The new paradigm is described, with empirical supportive evidence in the form of examples from current statistics literature, in a new article titled, "Where Statistics Went Wrong, Modeling Random Variation." The new article is addressed in my recent post of same title, on heimshore.blog. It may also be reached on my personal page at ResearchGate.
Thank you for listening. Until the next episode, goodbye.